We are trying to write the Vhdl code for this up-down counter entity, that is black box. We have the clock, we have the reset, we have the start terminal, we have the up-down terminal, and we have this output is of the 4-bit. I will start the discussion with library declaration. Here we have the library IEEE semicolon, then use IEEE dot std logic std underscore logic underscore 1164 dot all this library. Then we will use arith.all and unsigned.all, those libraries. Use IEEE dot std underscore logic underscore arith dot all, this library. Then we will use IEEE dot std underscore logic underscore unsigned dot all. These libraries we will use. Is it right? Now after this library declaration, we will go for some entity part. Is it right? Just I will zoom a little bit. Entity declaration. Otherwise, I will make it as 100%. Yeah. This is library declaration part we have completed. Now, entity. I will start with the entity declaration. It will start with reservoir entity followed by the name of the entity. In this case, the name of the entity I am planning, which is CNT up down. CNT underscore up underscore down. This is the name of the entity. Entity, name of the entity is. Then we have the port declarations. Is it right? How many ports we have? We have the clock, we have the reset, we have the start, then we have up down, up underscore down. These are the ports available in std underscore logic followed by the semicolon. Is it right? Then we have Q, or we can call it as counter output also. Q colon, this is out, and this is available in std underscore logic followed by the bracket followed by the semicolon, and here we have end name of the entity, and name of the entity is CNT underscore up underscore down. This is the entity declaration part. Look at this. This is the library declaration part, and this is the entity declaration. After the entity declaration part, we will start with the architecture. I will start with the architecture. It will start with reservoir architecture. It will start with reservoir architecture followed by the name of the architecture. Just wait. I will come back to you. I will come back to you. Yeah. This is, I will start with the architecture, reservoir. Here I will start. Name of the architecture, behavioral of name of the entity, which is CNT underscore up underscore down is. This is the declaration. Now I will complete this program by two ways. One by taking variable declaration and other by considering the signal declaration. In the last class I discussed the first, by using signal declaration and then by using variable declaration. Here I will do the reverse. Is it right? Now here is the begin of the architecture. This is the begin of the architecture. I always tries to mention all the declaration except variable declaration should be before the begin of the architecture. लेकिन यहाँ पे ये जो वैल्यू जो काउंट करना है और बाद में हमें क्यू को असाइन करना है, and this count value I am declaring this count as a variable, and at the end I will assign this value of the count to the queue. इसको दो तरह से कर सकते हैं. ये जो टर्म हम ले रहे हैं, this term may be the variable or this term may be the signal. If this term is the signal, then we have to declare before the begin of the architecture. If this term is the variable, then this should be declared before the begin of the process. Is it right? Because whenever we are using the variable, means obviously we are using the behavioral modeling which I have mentioned here. Is it right? Now this is the begin of the architecture because I am using it as a variable, so its declaration must be later on. Is it right? Now in this case, this is the begin of the architecture. Then I will start the process. I will start the process. Look at this process. In the process, I will put the sensitivity list, which is the clock, which is the reset, then start, then comma, up, down, up, underscore, down. This is my sensitivity list. Then if I want to declare this count as a variable, then variable declaration must be before the begin of the process. यहाँ पे होना चाहिए. Is it right? And here will be the begin of the process. This is the begin of the process. Now I'm using this term as variable, so I will declare here, I will show here the count. How is the declaration? It will start with the reserved word variable, followed by the name of the variable, which is count, followed by the colon, followed by its data type, and its data type is std underscore logic underscore vector. It is 3 down to 0. 3 down to 0. It's data vector. I will show it to you. How is this variable declaration? How is this variable declaration that I am trying to show you? Look at this part. It will start with a reserved word variable, followed by the name of the variable, followed by the colon, followed by its data type, and this is the initial value. This is optional. If your variable has some initial value, then you can put it. Otherwise, you can neglect this. Is it right? I'm using the same. It is the reserved word. Look at this part. This is the reserved word followed as variable, followed by the name of the variable, followed by the colon, followed by data type and its size. It is 3 down to 0 is my variable. Is it right? If I'm aware of that, variable is known, then I will define about its clock statement. Now, here is the begin of the architecture. Here, the circuit has reset. And I want to use this reset as asynchronous, means it should be outside the clock statement. Look at this, how I am planning that. Begin if reset is equal to 1, RST is equal to 1, then this count value is assigned as, now look at this assignment operator. Because I have declared this count as a variable, that's why this should be the assignment operator. The count is assigned as 0, 0, 0. Its initial value of the count is 0. Else if this clock is equal to 1 and this clock tick event, just wait, this clock tick event, then now this is the clock statement. explained this many times. In case of the synchronous circuit design, if we are using the clock for the circuit, this clock statement should not have the else clause. else clause nahi hona chahiye. Is it right? That's why इस statement को else नहीं आएगा. That's why I will use another if statement inside this statement. If start is equal to 1, start is equal to 1, then if start is a 1, then our counter should count up or down. Is it right? If start is equal to 1, then I want to use this counter. I will use another if statement here. If up underscore down is equal to 1, then if this is 1, then my counter should work in up direction. Then count is assigned as count plus 1. This is. If up down is equal to 1, then counter should count in up direction. Else, my counter should count in down direction. Else, this count is assigned as count minus 1. Else, look at this part. Look at this part. Here I am putting the logic. Just wait. Here I am putting the logic. Just wait. It is some incomplete statement. I will complete it first. This is if up down is equal to 1, then count is equal to count plus 1. I did some mistake here. I will correct that mistake first. This is not the end. This is else. Just I will correct it. Else, look at this part. It is else count is equal to count plus 1, and here it is the if. This is one if statement. And this if statement will decide counting up or counting down. If up down is equal to 1, it will start counting up. If up down is equal to 0, else means it is 0, it will start counting in down direction. But if start is equal to 1, then it will count up or down. Else if the start is not active, then my count is assigned as count. जो भी count का value है वो as it is रहेगा. Are you getting me? And then I will use the end if. Here is the end if. This is end if. Now look at the if statements, how I am using efficiently. This is another if statement which I have used for the start. Look at this. If start is equal to 1, it will count up or down. If start is equal to 0, counter will remain at the same count value where it was before that. अगर reset से 0 है तो इस start से पहले अगर 0 है, start 0 है तो 0 पे रहेगा. If otherwise हम किसी location पे उसको रुकाते हैं तो उस location पे. Then we have this another if statement, and its end if will be here. This will be end if for that if statement. Here is end if. Is it right? Now I am using this variable end if. I will end the process. I will end the process. Is it right? Now look at how we have to do. This variable we are using within this process. Within this process, that's why within that process we have to assign that particular value. Is it right? Count is in that process itself. Now, after end if, this Q is assigned as, Q is assigned as count. Then we have the end process. and finally here it is the end of that architecture, which is the behavior. Is it right? Now look at, I will give one clarification here. This variable count, look at this part. This variable count is not known to the system outside this process. इसलिए इसको प्रोसेस एंड होने से पहले इस काउंट का वैल्यू क्यू को असाइन करना है. अगर यही सिग्नल डिक्लेरेशन से अगर हम करते हैं, इफ वी आर ट्राइंग टू राइट दिस VHDL कोड बाय यूजिंग द सिग्नल डिक्लेरेशन, देन हाउ विल बी द चेंजेस दैट आई विल ट्राई टू मेंशन दो चेंजेस. उस चेंजेस को मैं मेंशन करूंगा यहां. Look at how will be those changes. If I'm writing this VHDL code for this using, I will use another color here, this color. Otherwise, I will use the yellow color, this color. It will give. If I'm using the signal declaration, in that case, how I should use? Signal declaration अगर use करना होता तो मैं कैसे use करता? Just wait. I will use another color because it is not visible. I will use this color. Count. तो यहां पे मैं सिग्नल डिक्लेयर करता उसको. Signal followed by name of the signal, which is count. Otherwise, I will write the separate program. I don't want here confusion. यहाँ पे मुझे confusion नहीं चाहिए. Is it right? Firstly, I will write the program for that also. This is using variable. Below this, I will try to write the VHDL code using signal declaration. तो दोनों का difference आपको पता रहेगा. I will use here. Because if I'm doing the changes there, you may be able to get the confusion. I don't want any confusion here. That's why I will write the VHDL code here. This library will be same. This entity declaration will be the same. I will start from the architecture. How is the VHDL code using signal declaration? That I'm trying to show you. Is it right? Look at this now. I'm writing the same code. Means what I mean to say here, the same code can be written by the number of ways. Just I'm showing some sample ways. Is it right? Now it will start with reservoir architecture. Followed by name of the architecture, which is behavioral. Of name of the entity. And what is the name of the entity which we have given? Count up down. We have given the name as here CNT underscore up underscore down. Is this name we have given, right? Architecture behavioral of up down counter is, and all the declaration should be before the begin of the architecture. If I am starting the architecture here, this is begin of the architecture. All the declaration except variable declaration should be here, and I am declaring it as a signal declaration. That's why my signal declaration should be here. Signal followed by the name of the signal. Name of the signal I am using the count, followed by the colon, followed by its data type and data size. std underscore logic underscore vector 3 down to 0. 3 down to 0. This 3 down to 0. Here is the begin of the architecture. Now in this case, now look at, I will write the code by comparing this. Architecture, here we have declared begin. Then I will use the process, and in place of this variable, we will use the begin of the process. This here, in this begin of the architecture, now I will use the process. I will use the process. Here is the process and process sensitivity list, which is the clock, reset, then start, then up down, up underscore down. These are the sensitive list we are using in the code. Yes, I'm coming back to you. Now here in the process, I will use the begin of the process because I'm using the sensitivity list here, and I'm using the signal. This is begin of the process. Here is the begin of the process. Is it right? In the begin of the process, इस process में हम यहाँ पे कैसा करें? यहाँ पे variable declaration था. In place of this variable declaration, I have declared it as signal declaration. Now this is the begin of the process. I will use the statement as it is. Up to this, the program will be the same. Is it right? Now look at how will be our code. How will be our code that I am using. Now begin. I will write here if reset is equal to 1, then this count is assigned as 0000 because it is 4-bit. This count value. Now this is assignment operator for signal. Means other than variable we are using this as assignment operator and this is assignment operator for variable declaration. यहाँ पे इसको use नहीं करेंगे. Is it right? Then I am using the clock statement. Look at here. Else if this clock is equal to 1 and this clock tick event. This clock tick event, then clock is equal to 1 and clock tick event means rising age of the clock. I mentioned many times this is clock statement and this statement should not have the else clause. इसको else clause नहीं होना चाहिए, right? So I'm using another if statement here. If start is equal to 1, if the start is equal to 1, then we have some part. I will use another if statement here. Otherwise, I will use another color. Here, this is if statement. Sorry. This is the if statement. If up underscore down is equal to 1, then if this is 1, it will count in the up direction. This count is assigned as count plus 1. Else, this count is assigned as count minus 1. This. And we will have end if here. End if. This end if is for this if statement. Now look at it. If up down is equal to 1, then it will count in the up direction. If up down is equal to 0, in that case, it will count in the down direction. Similarly, if start is equal to 1, then it will start counting, else it will not count. Means यहाँ पे क्या होगा? Here, else this count is the same as count. Count is assigned as same value, that is count. And we will have end of this if statement. Here it will be end if. Look at this part. This is another if statement, which is for the start. Then again, this is the clock statement. ये clock statement है हमारा. And this is the if statement of that clock statement. If else if में हम clock लिख रहे, बस इसको else नहीं होना चाहिए. इसके बाद directly यहाँ पे आना चाहिए. Here should be the end if. Here should be the end if. Is it right? Here should be the end if. And then we will have end process. Look at the difference. Here is end process. Now, what I am doing, now look at this signal is declared in the architecture. It is global for this architecture. Is it right? But in the variable declaration, this variable is local to the process. इस process को है. Process end होने से पहले इसका value हमें assign करना पड़ेगा output को. Means end process will be here, end of the process will be here. Before that, we have to assign that value to the output. Because end process होने के बाद इस count को कोई recognize नहीं करेगा, because count is defined within the process. After end of the process, no one will recognize to this variable. इसलिए पहले हमने इस count का value assign किया, उसके बाद end process, end behavioral किया. But in case of the signal declaration, we can end if, end process, and then we can assign this value of the count to the queue. This we will assign. And finally, this is end process, and this will be end of the architecture, which is behavioral. ये एक डिफरेंस ये हो सकता है और दूसरा डिफरेंस हो सकता है असाइनमेंट ऑपरेटर में और तीसरा डिफरेंस होता है डिक्लेरेशन में. सिग्नल must be declared before the beginning of the architecture and variable must be declared before the beginning of the process. That is the difference between writing the Vhdl code by using the signal declaration and using the variable declaration. That's it from my side regarding this.